If you want to learn Python, you need a really good plan. My name is Andrew, and today I'll give you your plan for learning Python. Let's start. The first thing that you need to do if you want to learn a programming language is learn about these things. That's your first category. And it's not a lesson, it's a category. Because you can have a lot of lessons in variables, types, if, else, and loops. But those blocks are the categories, and they're going to get progressively harder. So the first thing that you need to do, the first category, is variables, types, if, else, and loops. That will allow you to store data, to change data, to distinguish different types. So what is the difference between an integer and a float, an integer and a string, or some other thing, an integer and a boolean. Then you're going to use conditions. So if, else. You can say that if it rains, I'm not going to have an umbrella with me, or I'm going to have an umbrella with me if it rains. And you can do a lot of stuff with if and else. And of course you need loops to repeat your data, or to repeat your code, sorry. So what you can do with the first block, the first category, is you can store data, change data, distinguish types, use conditions whenever you need them, and repeat your code. So loops allow you to repeat your code multiple times. And if you know all of that, then we go to the next category, which is lists, arrays, set, tuple, and dictionary. So this category allows you to store a lot of data at once. So it allows you to store a list of your friends' names, let's say a lot of integers, a series of integers, let's say something. So you can store a lot of data with those kind of things, with lists, arrays, sets, tuples, and dictionaries. All of them store a lot of data, but how they store the data depends on the data structure itself. So you need to learn about all of these. And if you learn two of these blocks, you will be able to store data, use conditions, use loops, and store a lot of data at once. So store a list of your friends' names, for example. Then, once you know everything about lists, arrays, sets, tuples, and dictionaries, you need to go to the next thing, which is functions. That is yet the biggest category that you're going to have to learn. Functions allow you to repeat your code, so write a function and call it whenever you need it. And functions have a lot of things like returns, arguments, how you call function, high order functions, all that stuff. So you need to learn about functions, and if you learn three of these blocks, so if you know how to work with variables, lists, and functions, you can already switch the language if you don't like Python. If for some reason you think that Python is very simple for you, or Python is really hard for you, you can look for another language. And functions, lists, and variables are going to be the same, well, almost the same in every other language. The concept is the same. And you can already use some kind of programs, you can already write some kind of programs with these three things. But if you want to go further, there are two ways that I can show you. The first way is the simple one, and that way simple in terms of right now. So if you don't want to learn very, very hard stuff out of the functions, because functions themselves are hard, you can go to the thing called files. So you know how to write to files, you will know how to read from files, how to delete files, create files, and all that stuff. It will allow you to write a lot of programs. So let's say create a file that has all the names of my friends in it, or create a file that has all the logins and logouts of some kind of system. So just work with file system in your computer or on any other computer. And then what you can do is learn about pre-installed libraries, like a library called math. So you can use some kind of variables, you can use pi, you can use cosinus, sinus, and all that stuff. So you can learn about pre-installed libraries, and you probably used them before. So you probably used them in functions, maybe in lists, arrays, and sets, or in variables, types, if, and loops. So you already used those functions, those pre-installed libraries in your code, and you can use them after that, or you can learn about them right now. So pre-installed libraries is kind of like a thing that you need, and you need to learn about it. But if you don't know, you can just skip it for now. But it's a very good thing. You can do a lot of stuff with pre-installed libraries in Python. So you can learn about them. And pre-installed libraries are the pieces of code that you can already use in your programming language. But that is the easy way. So files and pre-installed libraries. The hard way that goes after the functions is the most important thing in all the programming. It's classes. So you need to learn about classes. And what are classes? Classes will allow you to model a real world in your programming language. And you're going to know how all the programs are written. Because if you only use functions, you can write some of the programs. But it's going to be really hard for you to think about other big projects if you don't know anything about classes. Classes is the biggest topic on that programming plan. And it will allow you to, once again, model the real world, and it's going to open up your eyes because you're going to know how all the programs like Instagram, WhatsApp, Facebook, YouTube, Google are written with the classes or with object-oriented programming. So classes, object-oriented programming is the thing that you need to learn. That's just the way. It's the hardest thing, but it will help you a lot. So once you know classes, once you know functions, maybe you know files, maybe you worked with pre-installed libraries, you definitely work with functions, you know about lists, arrays, and sets, and you know about variables. The next thing that you need to know is your project. Not to know, but to do, is your project. So what do we do here? Once we have enough knowledge to do something, we need to do a project. We need to create our own project. We need to make something with our own hands. Why is that? Because if you learn about something, like if you learn about classes, and you have, let's say you have a task to create a class called cat, you can create that class, but it will not show you all the intricacies of coding. If you have your own project, you know some problems, you know some mistakes, you know some errors, you know that you can have a bug in here, you know that you need to predict this, you know that you need to write your code in such a way that it works. And project will allow you to increase your knowledge dramatically. So once you know enough, so you know classes, functions, variables, lists, you know files and pre-installed libraries, you need to write your project. But here's the thing, even if you don't know classes, you can write your project with only functions, so with only 3 of these categories. You can write a project. Of course, it's better if you know about classes, because your project is going to be more complicated and more fun. And if you want a topic for the project, you can create anything that you want. You can create a game, you can create a bot, you can create a program that automates some stuff for you. So let's say you don't want to write your whole signature, your whole name, and whenever you type, well, my name is Andrew, whenever I type Andrew, it's going to add my whole signature to the text box that I'm writing in. So you can do a lot of stuff. You can do a game or make a game, you can, whatever you want. It depends on your preference, but you need to do that project. And you always need to do it before you go to the next part, even if you don't know classes. Well, you need to know them if you go to the next part, but project is really, really important. Once you have that project, you can already show something to your friends. You can already show something to, let's say, your teacher that works with you on that programming. But then what you need to do is you need to go to algorithms. Algorithms for search and sorting. Up until that moment, you knew that you need to write code to execute some kind of thing. You needed to write code to execute some kind of task. But we haven't talked about optimization and algorithms yet. Algorithms allow you to get to your goal. So do something with your code, execute some task. But the thing is that you need to optimize your code. Because if you write your code in such a way that it's messy, it's not optimized, so it's very, very complicated, then it's going to be really hard for other programmers and for computers to work with your code. Because let's say that you need to find a number from 1 to 100, so you have 100 numbers in your array, so in your array right here, and you need to find a number inside of that array. If your code spends 20 minutes looking for that number, it's not a good code. But if your code only spends 0.1 seconds, well, you won, basically. So you need to learn about algorithms, on how to work with complexity of those algorithms, how to work with the other things, and 2 categories of algorithms that can help you with that are search and sorting algorithms. You already know about lists, arrays, and sets, and all the other stuff like tuples and dictionaries. And you can search for a number, search for a value, search for your friend's name in a list of other people. You can sort some values, so sort random integer values from 0 to 100, or sort them in a descending order. We can do all of that. And algorithms for search and sorting will help you to understand how we can optimize our algorithms, how to measure the complexity of our algorithms, and it will just help you with understanding how to write code better. And then once you're finished with algorithms, you need to go to data structures. Data structures will basically allow you to understand how to store your data in such a way that it's more optimized for the computers and for your programs. Because algorithms will show you one important thing, is that nothing is perfect. there is an algorithm for each case. And sometimes what you want to do is not run an algorithm every time, but you want to store your data in such a way that it's optimized for search, or it's optimized for addition, or it's optimized for some kind of goal. And data structures will allow you to do that. You can learn about arrays, hash tables, and trees. And three of those things are really, really important because you already use them here. So you already used arrays with lists and arrays, you already used hash tables with sets and dictionaries, and you already used tuples. We haven't used trees yet, but three of those things are really, really important. And if you learn about data structures, it will show you how the insights of lists, arrays, tuples, sets, and dictionaries work in Python and in any other programming language. One important distinction is that data structures and algorithms are not unique. So they're not unique for a programming language. You can use them anywhere you want. Those are just the things that you need to do in order to optimize your code. So if you learn about data structures, it will allow you to understand how to store some kind of data in a specific case, in a specific scenario, and how all the pre-installed things like lists, sets, tuples, and dictionaries work inside of Python. Once you know about data structures, you need to go to the next thing, which is kind of like an easy category in our plan. Generators, iterators, and context managers. Those things allow you to work with Python better. So basically, let's say generators. They allow you not to waste a lot of memory on your data. Iterators, they allow you kind of to do the same. Context managers allow you to easily close and open your files. And those are just some of the examples. So you need to learn about these things to understand how Python implements some of the data structures, some of the algorithms, and how you can implement them in your code. It's not really important, so you can omit that step if you want, but generators, iterators, and context managers are really, really useful in Python programs, and you're gonna bump into a lot of them, so it's better to learn them right now. Okay, once you know that, you need to work on your second project, and here's the important distinction. You need to work on some kind of project that involves data structures, algorithms, and possibly generators, iterators, and context managers. But you need to know that your knowledge is not being wasted. So you need to use data structures and algorithms. You can do whatever you want. It should not be boring. So you can make, let's say you want to work with analytics. You can make a list of, or you can make a binary tree, so a data structure binary tree, and you can add a lot of values, or you can add some kind of statistic in that binary tree. And then if a user wants to look for a chance or a probability of something happening, you use that binary tree in order to show the probability, or you do some kind of thing. But you need to use your data structures and algorithms in that project. So that project is going to be far more complicated than the first one right here, because the first project only involves classes, files, all that basic stuff. But that project involves data structures and algorithms, things that you're going to use no matter what. So once you're finished with your second project, and once again, it can be anything, use your imagination. If you want, I can make a video on projects for Python developers that just started. But yeah, use your imagination, do whatever you want, whatever you like. Once you're finished with that, you go to the next block, which is, of course, progressively harder. Magic methods of classes. So we already talked about classes here. And you've probably seen some methods like underscore underscore init, underscore underscore, or maybe underscore underscore new, underscore underscore. And those double underscores are called dunders for a short version. So I'm going to call them dunders. And those dunder functions are called magic methods of classes. So magic methods of classes. What is that? Those are the methods that are used in order to do specific stuff with your classes. So let's say that you want to have two users and you want to say user 1 is equal to user 2. Without magic methods, you cannot do that. But with magic methods, you can do that easily. You can add different values together. So let's say that you have one array and the other array, or you have one binary tree from your data structure and another binary tree. You can say binary tree 1 plus binary tree 2. Those are your own classes and you can add them together. So magic methods just show you how your classes behave and how they work in their insides. That's just really, really important for Python, and a lot of things that you can use from those magic methods. And then we go to the next thing, which is patterns. Patterns allow you to write your code without any hassle. So pattern is basically a pre-built code. You don't need to invent your own pattern, And what you need to do is just understand how it works, copy it, or import it from a library, or use that pattern and use it inside your code. It's going to make your code better if you use the pattern correctly. It's going to make your code cleaner, and it's just going to be easier to work with your code. And patterns allow you to understand one important thing: how to write your code so it can be better in the future. Because when you write your code for right now, you don't really think about the future. But let's say that you had the game as your second project. So your second project is some kind of game, an RPG, and you have players with, or you have an enemy with a sword, so an enemy that attacks with a close range, and then you have an enemy with a bow. If you need to change something in your enemy with a sword, that doesn't mean that you will change your enemy with a bow. So what you need to do is use some kind of pattern that allows you to do that. Patterns will allow you to improve your code for the future and for right now. So you need to learn about those. And I want to say that there are lots of patterns, but learn about the most popular ones, like singleton, comment, factory, a lot of patterns, but learn about the ones that you think are useful. And once again, the most popular are probably the most useful right now. Okay, once you learn about patterns, you go to the next thing, which is really complicated. And one important distinction is that once you learn about patterns, you can say, okay, I can create some kind of project, and you can go to Django, you can go to web apps, you can go to analytics, you can go to automation, you can go to any kind of stuff. So patterns is really important. But all the things after that, important as well, but you can use Python on a really good level after you learn about patterns right here. So all the things that you learned before are going to be used in any language, and once you learn about patterns, you can switch your language once again, or you can use Python in a really good manner. So you can go somewhere deeper in a field that you wanna work in. But if you wanna improve your Python even further, what you can do is use these: solid, dependency injection, kiss, dry. When you learned about patterns, you learned how to just copy the code that is used in some case scenario, and then just use that code in that case. But here's the thing: you're not going to be able to copy some kind of pattern all the time. So you need to learn how to write a better code yourself. And what you need to do is learn about solid, so 5 principles of how to write your code so it's more maintainable, it looks better, it's cleaner, and so on. Dependency injection for people who really want to push the boundaries, because I think I'm the only one who actually uses dependency injections in Python. I've never seen someone use dependency injections if that's not my project. So dependency injection is really important, not only in Python, but in any programming language. Kiss, keep it stupid simple, or keep it simple stupid. A thing that allows you to keep your code simple, and how to do that. And dry, don't repeat yourself. Dry is one of the most important principles in all the programming. I think that's one of the worst mistakes that a coder can do, is repeat themselves. But all of those things allow you to write better code without using those patterns, because you need to adapt your own code, your own creation to one of those principles, to all of these principles. So it looks better, it is more readable, it is optimized, and all that stuff. So learn about these principles, and then you can go to refactoring. What is refactoring? It's basically changing your project or changing your code so that the features of your code do not change, so you don't add any new enemies in your game. But your game is more optimized, the code is better, it's cleaner, and all of the good stuff that comes with it. And why is it important that you refactor your project number 1 or project number 2, but don't create project number 3? Well, it's important because right now you learned about solid, kiss, dry, di, you learned about patterns, you learned about magic methods, and you already have 2 projects. And I would recommend you to refactor one of your projects. And if you refactor, you're gonna see the mistakes that you made before learning about all of these principles. And then once you refactor, first of all, your project is going to be better, so you can improve it even further. And second of all, your project, or you're going to see what kind of mistakes you make and how to prevent them in the future. So it's going to make you better as a coder. Once you refactor your project, so once you change it, you need to go to the next step, which is pre-installed libraries number 2. Pre-installed libraries are really important. And there are libraries like math, sys, os, path, and others that you're going to use anyway. So pre-installed libraries are just useful because there are no bugs in them. That's first of all. Second of all, they're already pre-installed, so you can just use them anywhere you want. Second of all, or third of all, sorry, they're really, really useful in some case scenarios. So you need to learn about pre-installed libraries here if you haven't done it before on this step. And even if you worked with pre-installed libraries here, still learn about them in this category, because pre-installed libraries have a lot of stuff. Like they have a lot of algorithms that you worked with here already built. The next thing that you need to learn about are tests. So tests and unit tests in particular. Why is it so important? Because you already created 2 projects and you refactored one of them. And you probably had something break, especially when you refactored your project just at a random point in your runtime. So while your program is running, it just breaks. Or you do some kind of stuff, you go to some kind of area, or you kill an enemy and your program just breaks. It just crashes. That's why you need tests. You need tests to show that your software is maintainable, that everything is predictable, you don't have any bugs, you don't have any, well, of course you're going to have bugs even with tests, but you significantly decrease the amount of errors, mistakes, and bugs in your code. So you need to learn about tests and unit tests in particular, because there are a lot of kinds of tests and you're not going to become a tester from this point, you're just going to learn Python. And unit test is one of the most popular tests in any kind of software, so use unit tests. Okay, and then we go to unique Python patterns. That step is really important because we already learned about patterns that are useful in any kind of language. And one important distinction, solid, dry, kiss, dy, and patterns are used in any kind of language, once again. So their implementation depends on the language, but the goal of the pattern stays the same. So you can use pattern factory in Python and in C++. They're not gonna vary very much, so yeah, those patterns are the same for any language. But there are unique Python patterns, and unique Python patterns in a sense that they allow you to make Python flexible. Let's say monkey patching. Let's say, I don't know, some pattern like, well, I call it error wrapper. So there are lots of patterns that you may use. But here's the thing. I said monkey patching, and maybe some of you who watched my videos or who know that monkey patching is kind of bad, know that monkey patching is kind of bad. And you already wrote the comment that, well, but monkey patching is bad, why are you talking about that? Unique Python patterns are useful, but Python is really, really, really flexible. That's its biggest achievement. Python is a really flexible language. And because of that, we can do a lot of harm, but we can also do a lot of good for our project. So we can allow unique Python patterns in our project to make the best code ever, to just do something that cannot be done in other languages. But at the same time, you need to be really, really careful with your Python patterns. And unique Python patterns, there are lots of those on the internet. They don't really have a name, but I talk about a lot of them. I talk about them on that channel. So subscribe and watch my other videos. Like you can watch a video about, I don't remember the name, but about wrappers, how they work, what is that? Decorators, another, well, decorator can be used in any language, but decorators in Python are, yeah, really useful. So unique Python patterns are very, very important because they allow you to look at Python code as a very flexible tool, but not flexible enough to break your system. So learn about unique Python patterns and unique stuff in Python. And then project number 4. And that is the whole thing, the whole plan that I have for Python programming language. Here's the thing. You're not going to learn about databases, about APIs, about web apps, analytics, I don't know, some other stuff that you want to work in with that plan. But your Python knowledge is going to be really, really, really good because you know everything that you need to know about that language. And if you learn all of that before you go to any other kind of system, any other specific field, then what you can do is easily take that field and learn it without any hustle. So you just get that field, you're like, okay, I want to learn databases. You get the databases, you know how all that works. Of course, well, there are things that you're going to need to learn and you're going to struggle with some of the topics, but it's going to be far easier for you to understand everything if you learn all of that. Of course, you can learn about, well, only these 3, you can learn about all of these and leave at the tests, unique Python patterns and all that stuff. But it gets progressively harder. And I think that is going to be really, really good if you learn all of that before you try to do something else. Once again, you are the programmer, so you need to decide. Thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment. Thank you for watching and good luck.